Okay, this is part 3, inverse functions. So we know we first start with just switching or swapping x and y. And I'm just going to rewrite over here. So 2y minus 3. So now just solve for y plus 2. So 2y is equal to, let's say, x plus 2 using commutative property. Then just divide both sides by 2. And that's going to give me y is equal to x plus 2 over 2. And we're just going to, remember, we're going to change that to the inverse of f of x. And x plus 2 over 2. Okay. So we want to see what this looks like graphically. So I took f of x, which is this function right here, and I just looked at all the points. So if you want to just maybe write that down real quick, x equals 0 and 1, 2, 4, and 6. Now put the y values here, so I'm just going to input those on the table. So it'll be 0 and negative 2, be 1 and 0, see 2 and 2, and 4 and 6, so 4 and 6, and 6 and 10. So remember, what would this look like if I were to graph the inverse of f of x? We're just going to switch these two, the x and y, we're just going to swap them. So instead of 0 and negative 2, it's going to be negative 2 and 0. Instead of 1 and 0, it'll be 0 and 1. Oh, 2 and 2, you just keep 2 and 2. So you flip the 4 and 6, and it'll be 6 and 4. And you flip the 6 and 10, it'll be 10 and 6. Okay? So essentially what you're doing is, when you graph this thing, say for example, this is our function f of x. You're reflecting it over this line y equals x. So the inverse is going to look like this. So technically, if I were to fold this paper, it would fold right on top of there like a mirror image, if you remember from geometry and reflections. So to make my graph nice and neat, I've actually graphed down a nice sheet of paper here. So if you've got the line y equals x, this is a quick review of Algebra 1. So y equals x, you know, if x is 0, y is 0, x is 1, y is 1, x is 2, and y is 2, and etc. so forth. So if you graph this, it's going to be a straight line like this, y equals x. So it reflects over this line, y equals x. Okay, here's what was our original function, f of x equals, let's just put it here. So y was, f of x was equal to 2x minus 2. And the inverse was, the inverse of x is equal to x plus 2 over 2. So here's our inverse function. And here's our line of reflection, y equals x. And here's our inverse function. So technically, if I were to fold this over, it will reflect right over that. So the inverse is to reflect over this line, y equals x. And all you have to do is swap x and y. Okay. So on the next one, I kind of want you to see if you can answer the following question. How do you solve this problem? What pattern do you notice? All right. It's pretty simple. Answer here. I'll show you guys the answer. Might be a little bit sloppy here. X and y are switched. The inverse is symmetric about the line y equals x. And if you fold the paper, it will fold over the line y equals x. But I do want you to try these last two problems. So you should be able to do that.